Hello, welcome back. Today in this video, we are going to see how we can implement chat memory in case of Spring AI using Cassandra. So in our earlier tutorials, we covered the basics of chat memory and how we can implement the same using JDBC chat memory, as well as we have seen the example using in-memory chat memory. Now in our this tutorial, we will implement the chat memory with the help of Cassandra. What we have done is we have created a simple application wherein we have added two controller classes, one for single user chat memory and another one for multi-user chat memory. So in case of single user chat memory, a single chat memory will be created for all the users that are using our application, whereas in case of multi-user chat memory, a separate chat memory, or we can say separate chat history, will be maintained for each of the user who are using our application. So let's start with the pom.xml. Here you can see we are making use of Java version 21, Spring AI version 1.0.0 milestone 7, and we have added couple of dependencies like starter web, which will help us to create the REST APIs, starter model OpenAI, which will allow us to interact with the LLMs. In our case, we will interact with the Google Gemini. Then we have Spring AI model chat memory Cassandra. This will allow us to create the memory data store using Cassandra, wherein our chat history will be maintained. And then we have Spring Boot Starter Data Cassandra, which will allow us to interact with the Cassandra database that we have. Next, coming to the application.yml, here you can see we have added the configuration mainly related to Cassandra, and then we have added the configuration related to AI, which is nothing but the LLM that we will interact with. So coming to the Cassandra part, here you can see we have configured the local data center as data center 1, which since we are running the Cassandra on a local system, we have specified the value as data center 1. Then we have specified the host of Cassandra port, wherein the Cassandra is listening. Then we have specified the username and password that will be useful for connecting to the Cassandra database. And we are passing the username and password via environment variables. Coming to the AI part, as I mentioned earlier, we have added the OpenAI dependencies, but we will interact with Google Gemini API, due to which we have modified the base URL, and you can see the base URL is of the Google APIs. Then we have also specified the model that we will be making use of. In our case, it will be Gemini 2.0 Flash. And in order to interact with the LLM, we need to specify the API key. So we have specified the Gemini API key, which will come from the environment variables. Coming to the configuration, so in order to interact with the LLM, we will make use of the chat client, and inside the chat client we will configure the chat memory. So first we have created a chat memory bean, which is Cassandra chat memory, and in order to interact with the Cassandra, we need the SQL session, which is nothing but the SQL session is required for interacting with the Cassandra, and with the help of Spring Boot auto configuration, it is configured automatically, and we will provide the same SQL session while creating the Cassandra chat memory. So here you can see we are creating Cassandra chat memory, and while configuring this, we are specifying the SQL session, and since we are making use of builder pattern, so we are just calling the dot build method. So the Cassandra chat memory bean is created. We will pass this Cassandra chat memory bean to the chat client. So here you can see we are creating the chat client, wherein while creating the chat client, we are specifying the chat memory, and also we are specifying the message chat memory advisor. So the role of this advisor is to get the memory from the Cassandra data store and add all the messages to the prompt, basically in order to create the chat history context, and so that the structure is maintained, we are making use of this advisor, message chat memory advisor, which will be responsible for the managing the memory, or we can say whenever we get some reply from AI or the input that we are passing to the AI, all those messages will be gathered by this and pass it to the chat client. Now coming to the single user chat memory controller, here we have created one simple chat controller with three endpoints, and the two beans that we have created like chat client and chat memory, we are configuring this inside the class. And then coming to the first endpoint, which is the chat endpoint. So this is the simple endpoint which will accept some input from the user and pass it to the LLM, and based on the reply that we will get, we will simply return that reply to the user. And whatever conversation which that will happen between user and the LLM, all that will be stored inside the Cassandra database. So here you can see we are making use of chat client, and whatever input we are getting from user, we are calling the LLM, and whatever response that we will get from the LLM, we will simply return it back to the user. Then we have the history endpoint. This is nothing but the chat memory that we have created. If we have to see how the data is stored in chat memory, we can make use of this endpoint wherein we will get the list of messages based on the conversation ID. Now since we are creating a application for single user, by default ID that Spring use while storing the conversation history is the default. That's why while retrieving the data from Cassandra database, we are specifying the ID as default. So based on default ID, it will get the list of messages and simply return it back to the user. And if we have to clear the conversation history or chat history, we have created the delete endpoint, wherein inside the chat memory we are calling the clear method, and we are specifying the conversation ID as default. So for the conversation history which is maintained, again this default conversation ID will be cleared. So let's, before jumping into the multi-user chat application, let's see this controller in demo. One more thing, coming to the Cassandra chat memory, when we start our application, the AI Spring AI JDBC Spring AI chat memory table will be created on the fly. So once our application is started, we can see I have connected the DB visualizer, and when I will refresh this, here you can see the new key space was created by Spring Framework with the name Spring Framework, and inside the tables you will see we have the AI chat memory table. So when we click on it, and we will see the columns there, we will have the four columns. First one will be the session ID, which is nothing but the conversation ID, and then the data that we will get from user, the input that we will get from user will be stored inside this column. The replies that we get from LLM or AI will be stored inside this column, and when the conversation happened at that time, the message timestamp will be stored. So initially this table will be empty, and as and when we will interact with the LLM, we will see that the rows are getting populated. So let's start with the simple single user controller. So for this we have this endpoint API chat, and I am providing one simple message, hello, my name is Bunty Ragani. So we will get some response from LLM with some greetings. Now when we refresh this table, two messages should be stored inside this. So let me see, just a second. So here you can see two messages are stored again, this inside this table AI chat memory, with the session ID as default, the timestamp when we receive the input or when we receive the reply, whatever input the user provided is stored inside the user column, and the response that we get from LLM is stored here. Now, when I ask the follow-up question, what's my name, then we will get a proper reply from LLM, because the conversation is stored inside the Cassandra database. So here you will see that LLM is providing me the correct reply. Now, in order to see what exactly stored inside the chat memory, we have the get endpoint API chat history. So when we click on history, we will get the four messages. First one was my initial message and the reply that we got from LLM. Second is the I sent up the follow up message, what's my name, and then we get the reply from. So this is how the data is getting stored inside the chat memory. And then we have the third endpoint, which is useful for clearing the chat memory. So when we click on submit, the conversation history got cleared. And also when we see the data of this table, then you will see the entire conversation history was deleted from this particular table. Here you can see the entire table is empty. Now we will jump to the multi-user chat memory, wherein you will see still we have the three endpoints. First, the API users, and then we have the chat endpoint, wherein we will accept some input from the user, send it to LLM, and whatever reply that we will get, we will simply return it back to the user. The only difference is now, since we want to maintain the separate chat history for each of the user, we are accepting the user ID as input, and then we are informing the same to the advisor, specifying that chat memory conversation ID will be this particular user ID that we will get from this input from the user. So what it will do is basically based on the user ID, the chat history will be maintained. For example, chat user A will have its own chat history, user B will have its own history. Similarly, while retrieving the content from memory, we are accepting user ID as input, and based on user ID we are searching the records in chat memory, and only the respective records will be written in response. Same, while clearing the chat memory, we are accepting user ID from user using the URL path variable, and based on user ID the conversation chat history for that particular user ID will be cleared. So let's see this in action. I'll restart our app. So for this, we will call our new endpoint, which is API users. Alice is the user ID that we are providing in input, and slash chat. So first message that we will send is hello, my name is Alice. So we will get some reply from LLM, and the same will be stored inside the Cassandra database. So when we will execute the query, so here you can see against the session ID, in the session ID column, Alice is the conversation ID against which two records are created, one for user and one for the LLM. Now next user comes in, let's say Bob. Bob is saying hello, my name is Bob. So for Bob, two separate records will be created against the ID Bob. So now for both the users, separate conversation history is getting maintained. Now we will see this in action, wherein first we are clearing the chat history for Bob. So now when we execute the queries, you will see chat history for Bob was cleared. And now when we will ask the same question to LLM, Bob is asking what's my name. Here we have specified the ID as Bob. Bob is asking what's my name. Since there is no conversation history maintained, we will get some error saying I have no memory of past conversation, therefore I do not know your name. Now when Alice is asking the same question, what's my name, we will get a correct reply because the conversation history of Alice is still intact. So when we perform the clear operation, only the conversation history was Bob was cleared, but for Alice you can see all the four messages are intact, and for Bob only two messages exist. That's we have seen just now. The Bob was, after clearing the memory, Bob was asking what's my name, and then we get some error which mention I do not know your name. So this was all for the single user and multi-user chat application. Now we will see some advanced configuration. So let's say when we started our application, at that time the key space that was created was Spring Framework, and the table that was created was AI chat memory. Now, if we have to customize this, then there are couple of options. For example, if you have your own key space, then while creating the chat memory bean, you can specify this like dot with key space name. While creating the Cassandra chat memory config, you can specify the key space name that you already have. And also, if you want to specify the different table name, then you can specify it using dot with table name. So based on the inputs that you provide in both, accordingly the table will be created within the specified key space name. Now, one of the feature of Cassandra is the time to live. So when we are storing our messages inside the Cassandra chat memory, we can specify the time to live, which means we can specify the expiry time for each of the entry. So how we can specify this? Same, while creating the Cassandra chat memory bean, inside the builder we can specify with time to live and the duration. In our case, each entry will be stored for 30 days. So these were some advanced configuration that we can do while creating the Cassandra chat memory. Now, coming to the logging part, let's say we have to debug what queries are getting executed behind the scenes. So what we can do is, inside our main class, we can specify a couple of parameters. So we will see it one by one. So first one is we have to specify all the configuration using system.set property. Here we are specifying the request tracker class as request logger, which will be useful for tracking. Then we have to enable the logs for success, logs for error, and if our queries are getting executed or if our queries are taking too much time, then we can enable that we want to print the logs for all of them, that is for success, for failure, for slower queries as well. Then we can also specify that if we want to see the values, what values we are getting passed while executing the queries, that we can set this parameter show hyphen values with true. And uh, we can also specify whenever the values are getting printed, what is the max length you want to print. So for each of the values, 200 is the maximum. You can configure it based on your requirement. And also how many values you want to print. For that we have the max values, we have kept it as 200. Now we will see one example. Let's say Alice is again asking what's my name. In that case, the select query will be executed, and also two insert queries will be executed, because one for user query and one the response that we got from the LLM. So when we click on this submit button, behind the scenes, you will see that the total three queries should be executed. First one is select star from AI chat memory, where the session ID is this. So we are, since Alice was asking this question, session ID is passed as Alice. And then we have two insert operation, wherein the question asked by Alice, what's my name, is stored inside the Cassandra AI chat memory table, and the response that we got from the LLM is also stored here, for which you can see one more insert statement. So LLM reply, your name is Alice, is getting inserted into the database. So when we check the AI chat memory table, two new entries will be created for Alice. So Alice was asking what's my name, and the reply that we got is stored in Cassandra chat memory. Yeah, so this was all regarding the chat memory implementation with Cassandra. We have also created a detailed blog wherein all the steps that we discussed are documented, along with the configuration options that we have seen. And also the example that we discussed is uploaded on GitHub. You can check out if you are interested. I hope that was helpful. Yeah, so that's all from my end. Thank you.